Om Sri Guru Basavalingaya Namaha. Okay students, yesterday we covered oxo acids of halogens. In them 4 kinds of oxo acids, that is HXO, hypohalous acid or halic 1 acid. Then second one, halous acid or halic 2 acid, HXO2. HXO3 is halic acid or halic 3 acid. HXO4 per halic acid or halic plus 7 acid. So halic will be 5. Here HXO, HXO2, HXO3, HXO4. It is hypohalous. It is halous, halic and perhalic or halic 1 acid, halic 2 acid, 3. Then halic 5 acid, halic 7 acid. Here fluorine, chlorine, bromine, iodine if you consider. For fluorine, HFO or HOF, whereas halous acid, halic acid, that is fluoric acid and perfluoric acid not possible in case of fluorine, right. Chlorine if you come, it will be HClO, HClO2, HClO3, HClO4, hypochlorous acid, chlorous acid, chloric acid and perchloric acid. If you come here, HBRO, HBRO2, HBRO3, then HBRO4. This is unstable. So now hypobromous acid, bromous, bromic and perbromic acid. Similarly HIO, HIO2, then HIO3, HIO4. These are oxy acids of halogens. In these oxy acids, suppose HFO is there, that HFO, H2O in the form of ice when reacts with fluorine to give hydrogen fluoride, along with that HFO. This is only one possibility is there. Come to the chlorine oxo acids. Generally we have in our syllabus chlorine oxo acids. In that HClO, if you consider, this HClO will be when chlorine reacts with H2O to give HCl with HClO. Chlorine when reacts with H2O to give hydrogen chloride along with that hypochlorous acid, or else chlorine monoxide upon hydrolysis with water to give 2 moles of HClO. Clear? In this way, here hypochlorous acid, its ion, suppose HClO is there, HClO get ionized into H plus plus ClO minus. ClO minus is the conjugate base of HClO. If it is weak, its conjugate base is strong. When ClO minus undergo disproportionation, ClO minus undergo disproportionation to give Cl minus and ClO3 minus. Here when 3 moles of hypochlorite undergo disproportionation to give chloride as well as chlorate. If you consider here, the oxidation number of chlorine is +1. Here the oxidation number of chlorine is -1. Here the oxidation number of chlorine is +5. Nothing but this chlorine from +1 to -1, 2 electrons are added. Same chlorine from +1 to +5, 4 electrons are removed. Nothing but one side it undergo reduction, other side it undergo oxidation. Thus hypochlorite undergo disproportionation to give chloride as well as chlorate. Clear? This step is important step here. Here preparations are not there, and one of the property let us cover. So that is hypochlorous acid. In case of hypochlorous acid, suppose ClO minus is there. In ClO minus, who is the central atom? Chlorine is the central atom. Oxygen is attached atom. Right? Now, if it is the central atom, around the central atom, how many atoms are attached? Only one atom is attached. So therefore, around the central atom, one atom is attached, plus group number of central atom is 7, oxidation number of central atom is 1 divided by 2. Already we know that these are the bond pairs of electrons, these are lone pairs of electrons. Now total number of pairs of electrons, 1 plus 3, 4, therefore S1P3, sp3 hybridization, 1 plus 3. So total number of pairs of electrons will become 4, therefore it undergo sp3 hybridization. In sp3 hybridization, one bond pair with 3 lone pair. We know that one bond pair with any number of lone pairs always linear in this geometry, linear in shape. One bond pair with 3 lone pair. Clear now? Similarly, if you come to HClO2 is chlorous acid. This chlorous acid preparation will be whenever the barium hydroxide treated with chlorine dioxide in presence of hydrogen peroxide. Barium hydroxide when treated with chlorine dioxide in presence of hydrogen peroxide, here 2 moles of chlorine dioxide will come forward. So that here barium chlorite, ClO2 add with barium. So barium chlorite, if you consider OH taken twice, nothing but 2 hydrogens, 2 oxygens, from which one water molecule, here one water molecule, hydrogen peroxide one water molecule. So total 2 moles of H2O. Along with that, here one oxygen left, here also one nascent oxygen left. Oxygen and oxygen liberates what? O2. Therefore barium chlorate is formed. This barium chlorate on second step, barium chlorite on second step with sulfuric acid get converted into barium sulfate along with the 2 moles of HClO2. Clear? There hypochlorous acid is going to prepare when barium hydroxide is treated with chlorine dioxide in presence of hydrogen peroxide. It converts into barium chlorite along with that water and oxygen. That barium chlorite when treated with sulfuric acid, suppose ready-made barium chlorite is available for us. This BaClO2 taken twice when treated with the sulfuric acid convert into BaSO4 plus HClO2. In this way, chlorous acid is prepared. Right? This chlorous acid HClO2 ionize into H plus plus ClO2 minus. ClO2 minus. This is chlorite. In chlorite, central atom is chlorine again. Central atom is chlorine. Therefore, around the chlorine, how many atoms are attached? 2 atoms are attached. Then group number of chlorine 7, and its oxidation number 3 na. X plus minus 2 into 2 minus 4. X minus 4 equal to minus 1. X equal to plus 3. That 3 we have to subtract from group number divided by 2. So therefore 2 plus 7 minus 3, 4 by 2 is 2 only. Now 2 bond pair and 2 lone pairs of electrons are there. Total number of pairs of electrons 2 plus 2, 4. So that 4 pairs will be S1P3. It also undergo sp3 hybridization. In sp3 hybridization, with 2 bond pairs and 2 lone pairs, bent or V shape or angular. Angular or bent or V shape. 2 bond pair with 2 lone pairs. Clear na? So this is HClO2. And next, chloric acid, HClO3. Chloric acid. This chloric acid directly when barium chlorate, this barium chlorate reacts with sulfuric acid, convert into chloric acid with barium sulfate. Barium chlorate reacts with sulfuric acid to give chloric acid with barium, double displacement. Here Ba is displaced hydrogens, that's it. This chlorate displaced by sulfate. Sulfate go with barium, chlorate go with hydrogen. That's chloric acid. Like this chloric acid is going to prepare. Right? So this chloric acid salts, if we consider salts of the chloric acid, suppose potassium chlorate. It is a familiar example. Many times we discussed with by taking an example. This on heating in presence of manganese dioxide, it undergo decomposition. During the decomposition, what will get? Oxygen liberates. Clear? No? So it decompose and liberate the oxygen gas. Clear? No? So in this way, the salts of this chloric acid, when heated in presence of catalyst, liberate the oxygen gas. Now this chloric acid, HClO3 ionized to H plus and ClO3 minus is a chlorate ion. Chlorate. Now in chlorate, the central atom is chlorine again. Around the central atom 3 atoms are attached, plus group number of chlorine is 7, oxidation number of chlorine 5 divided by 2. Therefore 3 plus 1 total 4. Again it undergo which hybridization? sp3 hybridization. sp3 hybridization with 3 bond pairs and 1 lone pair is a pyramidal, trigonal pyramidal. Clear? No? So here chloric acid in which the central chlorine atom undergo sp3 hybridization and geometry deviated from original tetrahedral with presence of 1 lone pair of electron. So therefore it is trigonal pyramidal. And finally perchloric acid. Perchloric acid is HClO4. How this perchloric acid is going to prepare? When ammonium perchlorate, NH4ClO4. Ammonium perchlorate formula that only na, NH4 plus univalent, perchlorate is minus 1. Plus 1 and minus 1. Therefore 1 cation is enough to form ammonium perchlorate with perchlorate anion. So that this ammonium perchlorate when treated with nitric acid which is diluted nitric acid when reacts with ammonium perchlorate will give perchloric acid along with that ammonium nitrate. Clear? So like this your perchloric acid is prepared. Ammonium perchlorate treated with the dilute nitric acid will give us perchloric acid with ammonium nitrate. Now in place of that ammonium, in place of that suppose potassium perchlorate, if you take potassium perchlorate when treated with the concentrated sulfuric acid, actually here perchlorate salt when treated with proton generating acid, this proton will be shifted to perchlorate anion, that's it. So therefore potassium perchlorate when reacts with sulfuric acid, 2 moles of potassium perchlorate is required. It get converted into 2 moles of perchloric acid along with that potassium sulfate. Clear now? In this way, here potassium perchlorate is going to potassium perchlorate with acidification sulfuric acid convert into perchloric acid. Here among all perchloric acid is a dimer. Sometimes they are going to ask. Dimer, here Cl, double bond O, double bond O, double bond O with OH. This is only now perchloric acid. In case of perchloric acid, here HClO4 ionized to give H plus plus ClO4 minus. In case of ClO4 minus, around the central atom 4 atoms are attached. Group number of chlorine 7, oxidation number also 7 by 2 equal to 4 plus 0, 4 bond pair with 0 lone pair. Total number of pairs of electrons are 4. sp3 hybridization without lone pair. Original structure. Original structure is tetrahedral. So this is a tetrahedral, right? And another perchloric acid, if you consider, another perchloric acid is in this way. It is also a tetrahedral. Now through intermolecular hydrogen bonding, between hydrogen atom of one molecule and other higher electronegative atom of oxygen belong to another molecule, there exists very weak electrostatic attractive force. Through intermolecular hydrogen bonding, here perchloric acid exists as a dimer. Clear na? So these are oxyacids of chlorine, and other oxyacids of chlorine regarding our syllabus point of view not much important. Chlorine oxyacids are important. Clear na? So these are oxyacids. In these oxyacids, some applicative questions also they may ask. Suppose HClO, if you consider HClO, in HClO, ClOH actually, or HOCl. HOCl, why ClOH I wrote? Central atom should be left side, attached atom should be right side. Clear na? Now this is OH. OH link with chlorine as a monovalent or multivalent? As a monovalent. Already this oxygen divalent, from which one monovalent linked with hydrogen, another monovalent left. Therefore we can expect it as ClOH, along with that 3 lone pairs are there. Clear na? Now its acidic nature is going to prove whenever this bond is going to cleave like this. Therefore no pi bonds. In hypochlorous acid, no pi bonds. Suppose if it is HClO2, again in case of HClO2, ClOH, one more will be as a double bond O. Now here 2 lone pairs are there. 2 lone pairs with 2 bond pairs. Around this total 4 pairs. 4. 1, 2, 3, 4. Therefore, sp3 hybridization with 2 bond pairs and 2 lone pairs, angular in geometry. It is a linear. It is angular. In this case, 1 pi bond is there. Clear na? 1 pi bond. Suppose HClO3 is there. HClO3, ClOH is common. Now, here 1 double bond O, here 1 double bond O with 1 lone pair. 3-dimensionally imagine this like this pyramidal. In this way. 1 is double bond O with OH. So therefore, it is 2 pi bonds are there. Here 0 pi bond, here 1 pi bond, here 2 pi bonds. Similarly, if you go to perchloric acid, Cl1OH is common. Here double bond O, here also double bond O. No lone pairs of electrons. Now heptavalency of chlorine is satisfied. No lone pairs of electrons. So therefore, here it is tetrahedral geometry, is no deviated original structure. Now here 1, 2, 3 pi bonds are there. In order to make the pi bonds, which kind of electron from chlorine is participating in lateral overlapping? There they are going to ask. See, without confusing, one of the complex molecule only let us discuss. Remaining you can easily follow. In this case, chlorine is a +7. Oxidation number of chlorine is +7. In that case, see, Cl atomic number 17 with neon 3s2 3px1y1z1 and 3dxy. See, here 3s2 3px2, 3py2, 3pz1 original. Correct? Now here these three lone pairs should enter into an excitation state. Therefore, chlorine electronic configuration in third excitation state. Correct? Chlorine electronic configuration in third excitation state will become like this only. Correct? In these, how many bond pairs of electrons are there? 4. 4 bond pairs. 4 bond pairs with 3 lone pairs of electrons. Correct? 4 bond pairs undergo sp3 hybridization. It is S, px, py, pz. S, px, py and then pz. So therefore undergo sp3 hybridization. sp3 hybridization with 3 unpaired electrons in d orbital only, na? Now these 3 unpaired electrons must overlap with the unpaired electron containing pz orbital of oxygen atom laterally. Therefore 3 pi bonds are there, na? Each oxygen here, each oxygen is having 3 oxygens are having double bond. One in double bond, in one this double bond, one bond is linearly overlapped with this unpaired electron. Now sp3 total 4 unpaired electrons are there. Now chlorine 1, 2, 3, 4 unpaired electrons linear overlapping. Along with that dxy, dyz, dzx. Therefore this is the dxy, dyz, dzx. Clear, na? Now d orbital is involved in lateral overlapping. D orbital is involved in lateral overlapping of oxygen unpaired electron. Oxygen is what? 2s2, 2px2, py1, pz1. Right? py1 already involved with linear overlapping of chlorine. Now pz is one unpaired. That unpaired electron of pz here laterally overlap with dxy, dyz and dzx electrons of chlorine. Followed? Here chlorine, these 4 electrons are sigma bonds. Suppose this is the chlorine having 4. Undergo sp3 hybridization I told. So this is 1 sp3, second sp3 and third sp3 and fourth sp3. Now with this oxygen py, with this oxygen py, with this oxygen py, with this oxygen py, and this oxygen is also having a pz. Every oxygen is having pz. That pz is with unpaired electron or not? Pz is with unpaired electron. With this pz, hydrogen s orbital overlap like this. This is the hydrogen. Now this oxygen divalency is satisfied, na? Here overlapping, here also overlapping. Now remaining 3 oxygen atoms, one pz is vacant. Vacant means without involved. Having unpaired electron, overlapping, no. Now here d, from d orbital how many unpaired electrons are there? 3. On this center, if I draw dumbbell shaped d, it will become highly complex. Therefore you imagine 3-dimensionally. So here this is like this laterally overlap with dxy. Here it is laterally overlap with dyz. Then it is laterally overlap with dzx. Therefore this is sigma bond, it is pi bond. Now this is sigma bond, it is pi bond. Sigma bond, pi bond. Here sigma and sigma. Linear overlapping only in s orbital. Sigma and sigma. Now you imagine this chlorine central 3 d orbitals. Therefore this pi bond is there, see, from oxygen p pi. Correct? pz hai na? This is a pz. And from chlorine d. Therefore p pi d pi. One p pi d pi lateral overlapping. Here second p pi d pi. Third p pi d pi. So now total 3 pi d p or pd. Correct? And here total 1, 2, 3, 4 sigma. So now 4 sigma sp3p. Correct? sp3 from chlorine side, p from oxygen side. 4 sigma sp3p and 1 sigma p and s. This is p, it is s. 1 sigma p and s, 4 sigma sp3p, 3 3 pi dp. Clear? Like this, in oxo acids, remaining you can imagine easily. Here only second excitation state, nothing but here one lone pair. Here one lone pair as it is. Now here electron will not jump. So therefore, in case of second excitation state, just here only I will rub and explain. In case of second excitation state, here this lone pair as it is, therefore here one unpaired electron could not jump. Now undergo sp3 hybridization, nothing but one of the oxygen is with lone pair chlorine. On chlorine, one of the oxygen is with lone pair. Here yes, lone pair is there now. In second excitation state, this lone pair as it is. And this is lone pair. These are the bond pairs, therefore pyramidal in shape only now. In that case 2 pi dp, 2 pi dp, and then 3 sigma sp3p, 1 sigma sp. Like that, if you come to one more in that way, you can expect so depending on excitation, how many d unpaired electrons are there, those involved in lateral overlapping. Regarding this, they may ask the question, how many, so on, so oxo acid possess how many pi dp bonds. Clear? Just you practice, then definitely you can get clarity. So these are oxo acids of 17th group elements. Clear? And next, the last sub-concept left in this lesson will be interhalogen compounds. Interhalogen compounds. Interhalogen compounds, internal, antargata. Suppose interhalogen compounds here 1x or else x2 if you take, x2 reacts with x dash 2. If it is one halogen, it is other halogen. Total 4 halogens we have. Those 4 halogens are fluorine, chlorine, bromine and iodine. In that, one of it I fixed as x2, other fixed as x2 dash. It is going to yield x dash, x dash taken n with the multiple of m. x2 when reacts with x2 dash, nothing but this here x2 is atomicity. Here also atomicity because divalent. Thus here m and n is going to decide, m and n are going to decide the formulas. Clear na? x dash, it is interhalide, internal halide, that is interhalogen compound. Interhalogen compound in which whatever x is there, this x must be larger in atomic size, x dash must be smaller in atomic size. Concept clear na? X, here x is larger in atomic size. Why? Left side whatever the atom we are writing, that must lose electron, that is electropositive. Right side what we are writing, that is going to take. Who is going to take an electron readily? Smaller the size of atom. If atom size is smaller, then effective nuclear charge will be more. The distance from the nucleus to outermost orbit will be less. Therefore easily that can accept an electron. Who is going to lose an electron? Larger size. Therefore x is larger size halogen atom, x dash is smaller size halogen atom. Now you can imagine fluorine never be acts as x because it is smaller. Correct? Fluorine never be acts as x. Suppose if it acts as x, it has to lose electron. Is that F is going to lose electron? 100% not possible. Now generalization followed. Suppose this concept clearly if you know, later you will not do the mistakes. Suppose interhalides as chlorine when reacts with fluorine, we may get 2ClF. 2 is m. Here F1 is n. Correct? Here m equal to 2 and n equal to 1. Chlorine monofluoride. Chlorine monofluoride. Now here bromine when reacts with fluorine may give 2BrF1. Iodine reacts with fluorine to give 2IF1. one kind. Generally here x dash 1 comma x dash 3 x dash 5 x dash 7, these four kinds of internal halides are possible. Correct? These four kinds of internal halides are possible. One more important point I will tell you. Observe, just by looking you can imagine. Here, as the ratio of radii of the larger size x atom to the smaller size x dash atom. Followed? Here, x radii to the x dash radii. Ratio of here radii of x to radii of x dash. If this is increasing, whatever the inter-halogen compound is forming, in that more number of atoms held. Suppose iodine, if I take, is a larger in size, x. Fluorine, if I take, smaller in size, smaller size enter into denominator, larger size enter into numerator. At that time the ratio will become more and more. So as the ratio of larger size halogen atom to the smaller size halogen atom increases, then in that internal halide or interhalogen compound, more number of halogen atoms are going to present. Nothing but in this combination, all total possibility IF7 is possible. That is XX dash 7. XX dash 7 only the maximum. Total 8 atoms are there now. 1 iodine and 7 fluorine. Now iodine atomic radii will be very much high. Fluorine very much small. Very much high to very much small ratio is a bigger value. Now as the ratio of radii of x to the radii of x dash increases, in that interhalogen compound more number of halogen atoms we may find. Clear? Na? Based on this concept you have to keep. Nothing but suppose if I take Cl and F, suppose Cl2 when reacts with F2 under condition, can I expect it as ClF7? Why? ClF7 is not stable. Suppose under condition if we prepared, it may exist. When the condition is withdrawn, again it will give back. Because Cl atomic radii, F atomic radii difference is not much. The ratio of the atomic radii of Cl to the atomic radii of F value is not bigger. If that is not bigger, in that internal halogen compound, internal halide, more number of halogen atoms we may not find. Therefore, ClF7 is not much stable compared with IF7. Clear? Na? Suppose there generalization question if they ask which among the following is more predominant. At that time what we have to do? The ratio of atomic radii of x atom to the atomic radii of x dash atom, nothing but larger size atomic radii of an atom to the smaller size atom of atomic radii ratio if increases, stability is more and more number of atoms we may find. Clear? Na? So here this is one slot as XX dash formula. Now x dash 3 is there, see. Almost all chlorine reacts with F2. Here equimolar ratio of halogen atoms. 1:1 molar ratio, 1:1, 1:1. Here Cl2 with 3 moles excess of fluorine. Excess of fluorine it get converted into 2 moles of ClF3. Clear? Na? 2 moles of ClF3. Similarly, Br2 also able to form with 3 moles of fluorine, 2 moles of BrF3. And I2 iodine with 3 moles of F2, now 2 moles of IF3. Clear? Na? In these 3 compounds, which compound further reacts with excess of fluorine to give more number of halogen atoms containing compound? IF3. Right? Directly halogen atoms in elementary form they may combine to give like this interhalogen compounds. Later here suppose ClF3 is there. This ClF3 further reacts with fluorine get converted into ClF5. Followed? Cl2 plus 3F2 gives 2ClF3. we may think that Cl2 plus 5F2 to give 2ClF5, right? But Cl2 plus 5F2 to give 2ClF5 compulsory should form through ClF3 only, na? Therefore, at ClF3 it attains some stability, and further enhancing condition that ClF3 further reacts with halogen to give ClF5. Followed? So here interhalogen compounds we may get direct treatment of halogens as elementary form, or else lower interhalogen compound when further treated with just halogen compound to give higher number of or more number of halogen atoms containing interhalogen compound, or higher oxidation number containing interhalogen compounds. Definitely in all the cases, whatever the X dash is there, always -1. Clear? Whatever the interhalogen compound is there, in that X dash is always -1. X oxidation number only going to vary. That fluorine losing electron never possible. So that X never be F. F could not act as X. Then excluding X, Cl, Br and I. Right? In that way, trihalide chlorine, trifluoride bromine, trifluoride iodine, trifluoride. Right? ClF3 with F2, ClF5. And finally, when iodine reacts with directly 7 moles of F2 get converted into 2 moles of IF7. Some condition will be 523 Kelvin to 573 Kelvin. Under this condition, iodine reacts with 7 moles of fluorine to give IF7. Clear, na? So in this way, interhalogen compounds are going to prepare. Now compare with halogens. Compare with halogens, interhalogen compounds are more reactive. Point you have to underline. Compare with halogens, interhalogen compounds are more reactive except fluorine. F2 is a halogen. That halogen is highly reactive even compared with interhalogen compounds. Excluding this F2, remaining halogens less reactive compared with interhalogen compound. Clear, na? Fluorine as halogen is more reactive. Excluding F2, remaining interhalogen compounds are more reactive than remaining 3 halogens. Chlorine, bromine, iodine. Compare with them, interhalogen compounds are more reactive. F2 is individually more reactive. Here interhalogen compounds, some bond dissociation will be very easy. Suppose if you take Cl and Cl, or else Cl and F. Here electronegativity difference is there. Here electronegativity difference is not there. It is a covalent. This shared pair of electron whatever is there equally shared by both the bonded atoms. But here unequal sharing is there. Suppose if you consider BrCl, here also these two are different atoms, or BrCl3, if you consider BrCl3 unequal. So therefore, here due to difference in electronegativity, it is reactive. The shared pair of electrons are not exactly shared by both the bonded atoms. These two bonded atoms are not exactly shared. Nothing but a shared pair of electron tries to withdraw towards more electronegative atom side. Whenever it is withdrawn towards more electronegative atom side, then definitely polarity taking place. When the molecule is polar, reactivity is increasing. Clear, na? Except fluorine. Why fluorine is more reactive? Even though here homoatomic molecule, correct? Both the atoms are same. But the thing is, due to small size, anomalous behavior of fluorine, due to small size, 3 lone pairs of electrons on this fluorine atom, 3 lone pairs of electrons are this fluorine atom. Among those pairs of electrons, repulsions are very strong. Due to the stronger repulsive forces, it readily involves in a chemical bond. Clear? So these are the reactivity of interhalogen compounds. Clear? And geometry. Again here, like oxo acids, let us check X dash. No confusion. X is central atom, X dash is attached atom, or X is with larger atomic size, X dash is smaller atomic size. Similar with oxo acids, this X is a central atom. Around it how many atoms are attached? Only one atom attached, one atom, plus group number of X, halogen is 7. Then what is the oxidation number of this? 1. It is X, it is minus 1. X minus 1 equal to 0, X equal to 1. So therefore 1 we have to subtract. Thus 1 bond pair with 3 lone pairs. Correct? 1 bond pair with 3 lone pairs, total number of pairs of electrons, 4. sp3 hybridization. sp3 hybridization with 1 bond pair and 3 lone pairs is a linear in geometry. Clear na? Linear in geometry. Similarly, XX3 dash if you consider, it is the central atom. Around it how many atoms are attached? 3. 3 na? Around it 3 atoms are attached. Group number of central atom 7. Its oxidation number 3. Here minus 1 into 3, therefore plus 3 divided by 2. So 3 plus 7 minus 3, 4 by 2 will be 2. 3 plus 2 will be 5. 5 will be S1 P3 D1. 1 plus 3, 4 plus 1, 5. So sp3 dehybridization. Tell me, sp3 dehybridization with 3 bond pairs and 2 lone pairs, T shape. sp3d will be trigonal, 3 gonals and 2 pyramids above and below. Here this trigonal planar, this is a planar, above one pyramidal and below one pyramid, right? In this case here this is central, it is X. Now it is X dash, then X dash. So therefore here lone pairs these two, thus it is a T shape only na? 3 bond pairs with 2 lone pairs, X dash. Now X dash 5, X dash 5. In this case, around the central atom 5 atoms are attached. Group number of this will be 7 minus oxidation number 5, because it is a monovalent, 5 are there, so it is plus 5 divided by 2. So now 5 plus 1, 7 minus 5, 2, 2 by 2 is 1, 5 plus 1 will be 6, S1 P3 D2, sp3 D2 hybridization, sp3 D2 hybridization with 5 bond pairs and 1 lone pair. It is not original, is a deviated, right? Deviated, here actually it is octahedron. Clear na? Like this. In this case, one of it is a lone pair, this is a lone pair. If it is X, here one X dash, here one X dash, here one X dash and X dash, here also X dash. Therefore what is this? Square pyramidal. This is the square, it is pyramid, correct? Here this is the planar square and above it will be one is there, is a square pyramidal. That square pyramidal is a distorted or deviated structure from octahedral. Clear na? So therefore here in XX5, XX-5 type, nothing but CLF5 is there. In CLF5 geometry, how can we say? In this Cl undergo sp3d2 hybridization, but with 5 bond pair and 1 lone pair. 5 bond pair and 1 lone pair always deviated, it is not original. Thus deviated from the octahedral will be square pyramidal. Clear na? Similarly, XX-7, XX-7, around central atom 7 atoms are attached, 7. Oxidation number of X 7 only. So group number of X minus this will become here 7 plus 0. Clear na? So total number of pairs of electrons 7. 7 out of 7 are bond pair. Therefore hybridization is sp3d3. sp3d3 is sp3d3 distorted octahedral, you can say, or geometry pentagonal bipyramidal. Pentagonal bipyramidal. 5 gonals are there. 5 gonals will be like this, 5 gonals and 2 pyramids, correct? 2 pyramids. If it is x, now these are x dash, 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 like this, right? So regarding inter-halogen compounds, in this way their preparation, geometry, reactivity, more number of atoms in inter-halogen compounds, how going to form? As the ratio of atomic radii of larger atomic size halogen to the smaller atomic size halogen increases, the number of atoms present in that inter-halogen compound also increases, stability also increases. Clear na? So this is 17th group elements according to your NCERT. Clear na? So mainly first in this lesson what we covered, who are the elements, why the name halogen term has come, who are the elements, their atomic number, their mass number, general physical characteristics, followed by general chemical properties, general physical as well as general chemical properties. Then after conclusion of that, next chlorine you have in your syllabus, chlorine methods of preparation, properties, uses, followed by hydrochloric acid or hydrogen chloride, methods of preparation, only one method is covered according to Glauber advised, then hydrochloric acid preparation, then its properties. Properties mainly aqua regia properties are very important. Gold as well as platinum is going to dissolve. The main reason to dissolution of that gold and platinum due to the formation of complex ions. Clear na? Aqua regia, what is aqua regia composition? Why that is going to form? Along with that, with the salts, how that is hydrochloric acid is going to react. Then with the bases, how hydrochloric acid is going to react, covered. And next, fluorine as a general chemical property only you consider. Suppose, sir, fluorine is not there in syllabus, NCERT syllabus, but on fluorine question has come, sir. That question based on general chemical properties. Clear na? General chemical properties. Then next, oxo acids, 4 kinds, HXO, HXO2, HXO3, HXO4. Actually in your syllabus preparation and property also not there, just geometry. Then the pi bonds in what way are there? P pi, P pi, P pi, D pi and sigma, and then interhalogen compounds. Clear na? Then oxides of chlorine also covered, Cl2O, ClO2, Cl2O3, Cl2O4, Cl2O6, Cl2O7. Clear na? So their preparation, properties, uses we have to cover. With this P block 17th group elements we concluded, and next class we are going to discuss entrance questions on them. Those entrance questions I will display on screen, and on screen itself by reading that question you can observe. This is visible even through online also to your mobiles, we may send that plan is going on. Right, thank you.